And like I was saying, today is really going to be a review of where you started yesterday. We'll be expanding on what you all built with the PeopleGetter application. And then we will be kicking off a 2-day project that you all will be doing in groups. So, full stack web application, PeopleGetter part 2, and group project. Yesterday, what you started with the basic full stack tech stack is essentially an application with 4 components. A client that allows users to interact with an API through something like browser, through curl commands, through Postman. And then you have a web server that hosts this client connection and interprets the client interactions, which it then sends to the app server, which routes the client server-side requests to the appropriate API endpoints. And finally, these interactions will interact with the data stored inside the database. The basic flow of this, am I sharing my screen? I am, right? Yes. No, I'm sharing the wrong screen, I think. Sorry.
Yeah, we just see your drive.
All right, let me switch back to the right screen. Let me back up a bit. These are the 4 components that make up our basic tech stack: client, web server, app server, and database. And the basic flow is this. You have a request that travels from the client to the web server, which is then interpreted and sent to the proper API, which then affects the data inside the database. And on return, the database data is sent back to the API, which sends it back to the client as JSON. Can anyone tell me, what is the key problem with the current state of the PeopleGetter application that you all built yesterday?
It's only accessible to those running the Docker containers.
Exactly. Non-deployability. Can anyone, well, actually, Tyler, you pretty much answered that too. Why is PeopleGetter currently non-deployable? Like you say, it's only accessible to the people running the container. A local server is not a web server. A local server is accessible only locally. So what we're going to do today is implement a simple web server. And the easiest way to implement a web server is to utilize an existing web server application. And that's where Nginx comes in. Nginx is an open source and readily available web server that has official Docker support. So once we containerize the front end to use Nginx to handle the client requests, this is what our full stack application will look like. We'll have a client that uses your browser to communicate with the Nginx container, to communicate with your Python API backend, which CRUDs data inside your Postgres database. So let's get started by talking through the repo that you'll be forking today. You'll start by forking and cloning PeopleGetter 2. So let's pull that up. Oh, actually, no, that's not the right thing. That's for a little later. People server 2 is right here. You will fork and clone this, and you will run, according to this documentation, the start all shell script. This script will perform these 4 steps. It runs a DB setup script. It dynamically grabs the container's IP address and writes it to the DP IP address within the API folder, and then it runs the API start _ API script, and then it runs the front end script. The DB setup script itself looks like this. It's a very simple 2-line script that builds an image from the Docker file, which it then runs as a background process. This service needs to be running before the Python API container because the Python API needs access to the database's IP address, which is assigned by Docker when it is spun up. It also contains a preloaded person table, which is essentially what the database is. The next thing it does is it runs this Docker inspect command, which is how it dynamically grabs the IP address using these variables, which it then writes to the API/db underscore IP underscore ADDR parameter. And then it runs this following script, which is another simple Docker build and Docker run script. And this spins up the API portion of the application. And finally, it runs one more script, which spins up the front end server. Any questions so far? Awesome. So that is actually about the extent of which I was able to get through. So let's switch gears to the group challenge. The group challenge is going to be a group challenge. You will all be split up into 3-person groups. And as a group, you'll be creating a very similar full stack web application utilizing the same architecture. A client that uses a browser, a web server that utilizes Nginx, an app server that utilizes Python, and a database that is written in Postgres. Same diagram, and because Chad really wanted to emphasize this point, because you'll only be working on this for 2 days, keep the application as simple as possible. The more important thing is that the application functions and that it accomplishes the goals, the objectives of this challenge. So don't get carried away with the creative or fanciful aspect of what this app can potentially be. You'll have your final group project to do all that wild stuff later on. For now, we really only care about you following this very similar architecture and getting the foundation down, which you will repeat later on because repetition builds experience. So we will allow Zoom to create those groups for you. But let me ask you all right now, would you prefer to jump straight into this, given that we're a little behind, or would you like for me to demo People Getter Part 2 before I break you up into groups?
I'd be
Do you
fine to
mind
just,
just go ahead, Ken?
I said I'd be fine to just jump in.
Cool. Okay. Anyone else?
So yeah, so are we using the Docker Nginx? Is that how we're doing that for the web server?
I believe so, yes. So maybe if you want to figure it out on your own, I could break you up into groups and you could just dive right in. But I could also create an additional breakout room where I'll demo People Getter 2 so you could see how that's done if you want to see that as well. How does that sound?
Yeah, that's fine. I mean, I can give it a shot.
Okay.
I think with a group would be fine.
All right. Tomioa, I think you were gonna say something, or was it the same as what Chris was gonna say?
Yeah, I'm fine with a demo.
Okay. Cool.
Yeah,
Oh, sorry. Go ahead, Tyler.
I was just gonna agree with Tommy.
Okay, right on.
Yeah, if you're gonna do a demo, I feel like might as well stick around for it.
Yeah, I feel like I'm up for a demo as well because the Nginx part seems a little confusing to me.
Okay, cool. So
Yeah.
we can do a demo. Right on. All right, let me pull up. Actually, let me pull up the chat just to see what everybody else is saying. Okay, same thing. We all want a demo, so let's do a demo. Right on. Okay, so we're still sharing this. I actually already have People Getter 2 spinning up, so let's run back to People Getter 2. All right, I'm going to switch screens to my Actually, I should just share this entire window. So let me do that. Okay. Share this. We are going to pull up this. Right now, I've got people getter 2 spun up. There is yes, a people front end and a people API. And we are looking for the front end. So let's find the index. Let's open it up with live server and let's see what we are looking at. Bam, this is the application. Let's see what it does. We can grab. It looks like it's not doing anything. Can anyone tell me why?
You start the server?
Good call.
Do you need a cores header?
Do I? It looks like we do. So where are we at? We have spun up the script. We are using the live server extension to open front end index.html. It talks through the 4 things that it does. And then the front end folder contains everything you need for a web server. It utilizes the Alpine Nginx image. Configuring a web server can get complicated, but fortunately, all the default configurations will serve our purposes for now. So we're going to have to troubleshoot this and look into our configurations to see why this isn't working. So all we have to do is copy our HTML, CSS, JS files to user /share /nginx HTML within the container. Okay, that sounds simple. So let's see what we have here. We've got a user folder, or we don't have a user folder. Maybe we got to backtrack a little bit more. So all of this should have occurred already because I ran the start all script. The database folder contains everything that we need to run a containerized Postgres database. I can see that the people API is up. Is the people database up? That might be what we are missing, like somebody pointed out. Let's see. The setup sh script will build the image of a Docker file and run it as a background process. The service needs to be running before the Python API container. So let's see. I will do another Docker PS because I had this previous command open up earlier. It looks like I have the front end, I have the API, but I am missing the database. So let's look at the database setup shell script, and let's see why that didn't run. I'm going to actually use the front end for Docker Desktop. And I see that even here, there is not a container for people_db. So I'm going to scroll up. I'm going to look through my logs and see what happened. Aha. When I was running the script, it looks like PG_db was already in use by a separate container. So Let's find that PG_DB and let's get rid of it. Should be used by this container. Yikes, I don't remember which one it is. I might have already nuked it. I'm just gonna nuke all of these. And then I'm gonna manually run this command. I'm gonna actually stop these servers as well. And I'm just going to go ahead and run the script fresh. So I am inside my repo. I'm going to run startall.sh. Let's take a look. Now we have people DB up, we have people API up, and we have people front end up. So let's take another look at our front end and let's see if it performs any differently now. We now have access to the database. Simple fix, just had to troubleshoot why the database didn't load, and our logs told us that there was a conflict which caused it to not load. Now that it's loaded, let's take a look at what else needs to be done in this exercise. Front end folder contains everything you need for a web server. It uses the Alpine Nginx image. I'm gonna open that up. Oh, I already have that open. So it says all we have to do is copy our HTML, CSS, JS files to this location. So it looks like the Docker file is set up to already pull this container and to copy the index HTML, style, and app into this user directory, but we don't have this user directory.
Would that directory be in the Docker container?
Yes.
Like that? Yeah.
Very good call out. Thank you. Was that Philip?
Yes.
Right on. Very good. That is exactly what is wrong right now. So let's hop into our front end and let's take a look at what's going on here. Going to user, I'm going to go into, what was the directory you wanted? I wanted the share folder. So everything might actually already exist where it needs to be. So let's look inside of Nginx. Is that what it wants? Yep. And then we see inside of HTML. So wow, this is even simpler than I thought. You're basically, in this exercise, running a command that already does all these steps for you. So that's the demo. I mean, if you want to see what pulling this container looks like, let's walk over the front end Docker file. Again, it's basically pulling from Nginx, the Alpine build, and then it's copying these files into this directory. So when you build your own full stack application as a group, you're going to be writing out a Docker file very similar to this. And that is about all you need to do to spin up Nginx. Cool. How do you all feel right now? Ready to go? Cool. I will stop the recording.